Hello, welcome to the last lesson in Chapter 7. This is Lesson 8 on geometric sequences. By the end of the day, you'll be able to write and use recursive formulas for geometric sequences and explicit ones too. But anyway, I just got so excited. Okay, so we've seen arithmetic sequences before. An arithmetic sequence is something where we have like a of n, and then you have, 2, 5, 8, 11, etc. And you have a common difference, we said. Here it would be 3 because you're adding 3 each time. Here in a geometric sequence, it's not a common difference. Instead, you have a common ratio. Ooh, the ratio of any term to its preceding term, that is the next. Actually, in this case, this is previous, the one that comes before it, is constant. So what that means, if you have like term 1, term 2, that's always going to be the same ratio, fraction. Okay. So if you have a geometric sequence with your initial value or your starting value of A and your ratio, watch this, energy efficiency right here, yoink, your ratio is R, it's always going to look like this. So you start it with A, yay, put the A in yay, and then you multiply times R each time. So A times R. Oops, A times R. And then you multiply times R again. R times R is R squared, so that's what you get. And then you multiply times R. A times R squared times R is R cubed, still times A. Man, this was not meant to look so Christmassy or watermelon-y, I guess. Anyway, notice each time, as you're multiplying times R, the exponent increases. So your exponent, if this was a 1, and this is R to the 0 with, your exponent goes up by 1 each time. That is not a coincidence. So notice that pattern. Still Christmassy looking though. So, is the following a geometric sequence? Well, do we multiply by the same thing each time? And I know we're super tempted to read left to right, but I actually encourage you to go the other way. And do your dividing guy. What is 20,000 divided by 2,000? That's 10, right? And what is 2,000 divided by 200? That's 10. And what is 200 divided by 20? Wow, guys, look, it's 10. Crazy. Because it's 10 each time, that means 20 times 10 is 200. Times 10 is 2,000. Times 10. Oh, oops. Oh, we're multiplying by the same thing. Yay! Yes, this is a geometric sequence. Okay. B. Is this geometric? Oh, 2 times 2 is 4. 4 times 2 is not 6. So no. We're adding. This is arithmetic. This is not geometric. What about C? What? Here we subtract 10, and then we add 10, and then we subtract 10. That's crazy. That's also the wrong way to think about it. Remember, we are multiplying. What are we multiplying here? We're multiplying by the fact that I cannot draw an arrow to save my life. Just kidding, there it goes. Multiplied by -1 times -1 times -1. Woo, it worked! What? What is this? Well, how do we get from 10 to 5? We can divide by 2, and 5 divided by 2 is, well, 5 divided by 2. Oh, I wrote divide by 5. Okay, and then we divide by 2 again. Yes, but, guys, geometric sequence is when we multiply by the same thing. So this is, oh, I forgot, this is a geometric sequence. Okay. So if we're not multiplying, is this geometric? It is, because we are multiplying. I fooled you. It's times a half each time. So yes, this is arithmetic. No, I lied. Yes, this is geometric. And then I got the hiccups. That's what I get for being a liar. Okay, we're going to talk about two different definitions. A recursive definition is a definition that's recursive. Ha ha. I'm just kidding. It depends on itself. A recursive definition is like going in, it's cursed. I'm just kidding. It describes itself. It needs itself to describe itself. It's super circular. Anyway, so what we need is we need our initial condition, the thing at the start. We need our first term. We call it a sub 1. Okay. And then we also need our next term. We need to figure out, okay, well, what do? We go our next term times the previous term. Oof. So if we want to find what our previous term was, we say, okay, well, I'm sorry. I don't know where I'm going with this. If we want to find a term, if we want to find some term a sub n, then we need to take what the previous term was and multiply it by r. So if I wanted to find, okay, well, what's the next term of this sequence? We'll say, oh, well, just look at what came before it. Multiply it by -1. Okay, cool. Yeah. I really don't like recursive formulas because you need to figure out all the things that came before them. I much prefer explicit formulas because an explicit formula lets you find whichever one you want at any time ever. So how you find this is you use our exponential growth function. Because check it out. That's literally what we're doing. Except our starting value is our a sub 1. We call it a sub 1. It's not just a this time. It's a sub 1. Hee hee. And then our growth factor, well, we've just been calling it a ratio this time. It's r. Our growth factor is r. Whoa. And instead of finding the xth term, we're just finding the nth term. So we say a sub n is equal to a sub 1 times r to the n minus first power. Sorry. Haha! Great, right? And you know what, guys? This right here is all we need. So I'm going to rewrite them nicely. Okay, so as long as we know our initial a1 and we know our rate r, and we want to find our nth term n, then we can do one of two things. We can use the recursive. Recursive says, okay, we'll say that a1 equals whatever it is, some number, and then a sub n is going to be equal to a sub n minus 1 times r. Ta-da! Oh, I'm sorry. If we want to find the term, that's a sub n. That's the nth term. Yay! Okay, cool. So that's recursive. And then the explicit one says, you know what? If you don't know the term before it and you just want to find, hey, what is the nth term? Well, just take whatever your first term was, multiply it times r, n minus 1 times. And now you're done. Yay, key idea. There it is, all in one spot. Woohoo! Okay, so now we have to find the recursive and explicit formulas for each sequence. Oh man, if only there was some like pattern or shortcut we can follow. Oh look. I found it. Okay, well let's define. What is our first term? Our first term is 3. So a sub 1 is 3. Cool. What is our rate? Well, here we multiply times -2 times -2 times -2. So every time we have R, that's a -2. Oh, look, we're done. Yay! We are done. Next one. Okay, let's identify. Oh, spelling recursive correctly. Woo! What is our first term? Our first term is 16. So we're going to get rid of, whoa, there we go, 16. Boom, boom. What is our rate here? Well, we have to multiply, again with the sad arrows. Multiply times 1/2. Well, 1/2 each time. I run out of room. So every time we have an R, our growth rate is 1/2. You can write 0.5 if you want. I like fractions. So we're going with fractions. Ta-da! Okay, cool. One more model, and then we'll call it a day. So this is a true story. I used to work at a clothing store. Had a lot of sales a lot of the times. And here's the patterns that they followed. Also on your nose, I forgot to put the Christmas graph. I don't know what happened. So I just went and I graphed it myself for symmetry. So if you want to look at it, you can. Anyway, so at Christmas time, we had this sale. Now, how can we figure out an explicit formula here? Well, let's find our explicit formula. Yoink. Yoink. Okay, so here our first term is 60. So to find the price of a shirt that's been marked down n times, so maybe it's like after n weeks or whatever, a shirt that's been marked down n times is going to be 60 times our rate. What is the rate here? Ugh. In order to find it, we have to work backwards. So we need to figure out, okay, what is 36 divided by 60? Or what is 21.6 divided by 36? Each time you'll say, hey, it's 0.6. Cool. So to go from 60 to 36, you need to multiply times 0.6 each time. And do notice that that pattern carries off. And this is actually a true story. The store that I worked at would have 40% off sales all the time. That would mean you're paying 60% of the original price. So our rate is 0.06 to the n-1th power. Quick, where does this n-1 come from? Well, notice that 60 is our first term, 36 is our second, 21.6 is our third. This is at 0 mark-offs. So we do 60 times 0.6 to the 0th, which is 60 times 1, which is 60. Here, there's been 1 mark-off. We multiply by 0.6 one time. So to find our second term, we only multiply times 0.6 once. So this is our formula. Now, after the 6th mark down, that's going to be, oh, just kidding. After our 6th mark down, that's going to be our 7th term of the sequence, actually. Because this is 1 mark down to get the second term, 2 mark downs is our third term. So we would actually find out, okay, well, A sub 7, our 7th term, is 60 times 0.6 to the n-1th power, but this, we're finding the 7th term. So we plug 7 in there, but you notice right away that becomes 0.6 to the 6th power because it's after the 6th mark down. So that's how that works out nice. By the way, this shirt will be on sale for $2.80. So clearance, yes, because 6 markdowns, guys, that's excessive. Anyway, what about this guy? How can we write an explicit formula for the Labor Day sale? It's not nearly as good as the Christmas sale. As you can see, it only hops down to 48 instead of 36, but that's not going to stop us. We can still find our initial value. Easy peasy lemon squeezy. Ta-da. This is the first one. First things first, get that out of the way. Yay. Okay, now we need to figure out what is our rate here. Well, if you can look at this and see, wow, I see that 60 times something equals 48. That's great. I can't. So I need to go backwards to figure out what that is. What is 48 divided by 60? If you would rather do 38.4 divided by 48, all the power to ya. In fact, you should be doing all of these just to make sure it is the same rate the whole time and I'm not messing with your heads or making an honest mistake. Either way, you will figure out that you multiply times 0.8 each time. So we're multiplying times 0.8 to get to our next markdown. This tells us that r is 0.8, so go 0.8 to the n minus 1th power. Ta-da! Okay, if we want to find after the 6th markdown, we have a of 7 equals 60, 0.8 times, or to the power of 7 minus 1, which is to the 6th power, which comes out to 15.73. We can check this by saying, hey, what is our graph at when x equals 6? Is it approximately $15? Oh, yes, it is. Good job, computer and our computer-generated graph. That is perfect. Well, is this approximately $2.8? You know what? This graph would have been, look at that. I would have kept it going. Yeah, totally. That would have been, yeah, totally. Good job, hand-drawn graph. Okay, well, anyway. Remember your key ideas right here. Know them, love them. Recursive requires the term before it. Explicit is, you can plug in any n to find any term, anytime, and you have a great time on your homework.